Good afternoon. Я буду говорить по-английски, sorry.
As you like.
Мы уже слушали сегодня достаточно новых слов, я не хочу добавлять к этому словотворчеству, поэтому я буду говорить по-английски. So, first of all, I thank organizer for inviting me to my alma mater. I don't remember how many years passed since I talked in Fistech. This talk is, I do it on behalf of a team, and one of members of this team, Dima Kazakov, is here, who helped me to prepare this talk. So, this topic is about drug discovery using the approaches which were developed by this team of us. And the major issue is that there are two types of drugs. One type which is exploited very much, has been exploited up to now. It is when you have some protein and you have the cofactor, and this cofactor may be replaced by the drug, and as a result of this replacement, the protein is inhibited. And it is really a lot of drugs based on this principle, but not that much exploited situation is when we have protein-protein contact, or protein DNA, or protein nucleic acid in general contact, and it does not include some specific cavity. And the challenge is to develop a drug which will interact to this more or less flat surface of the protein and inhibit the interaction, protein-protein interaction. So this is PPI, which will be used in slides, is protein-protein interaction. But we talk about more general situation, not necessarily protein-protein, but also protein-nucleic acid interaction. So that's why we call it macromolecular interfaces. So this is the major issue we focus on, the development of drugs which interfere in protein-protein and protein-nucleic acid interfaces. Of course, this is understood for a while, the importance of this kind of drugs, and a big pharma already exploiting this opportunity. And but I will tell later what is our approach, original. And so we have two essentially ways to do this, to develop these new drugs. You can do it by exploiting really huge different screened huge set of possible molecules, and you can decrease this set by 10 times at least, but when you do it by fragment-based approach. So this fragment-based approach is more economical because you don't need to test that many different potential drugs. And what is done in this normally in this respect is to find the hotspot on this more or less flat surfaces I talked about, and these hotspots are you have ranking depending on the affinity between these fragments and protein molecules, and this is done traditionally with the help of X-ray crystallography or NMR of these small fragments with proteins. And you find the hotspots for these fragments, and then you determine these hotspots using this experimental approach, X-ray or NMR, and then you get consensus hotspot where different small fragments find this hotspot independently, and when you have this combination, this is hotspot which is essentially the candidate for further development of the drug. And this is how big pharma is doing it, but it is really very expensive and time and labor consuming approach. So what team I am talking about is doing, we're doing this with our innovation, is that we replace this experimental approach, purely experimental approach, with computational approach. So essentially what we are doing is in the same way, in the same line of thought as these guys who got Nobel Prizes here in chemistry, Martin Karplus, Michael Levitt, and Ari Warshel pioneered this molecular modeling and finding the energy of interaction of molecules with proteins and which proteins with each other. And so this, of course, they were pioneers. Since then, these approaches have been significantly perfected. And as a result of this, we can do this computationally, this determining hotspot. And this is what our group significantly contributed recently and developed very good, very efficient software to do so. And so what we suggest potentially as a new lab on FISTIAC is to do this kind of early drug discovery using first computational approaches we developed, and then complement them with experimental verification of these hotspots and these potential drugs, and study them using X-ray and NMR approaches only after, not starting with this as Big Pharma is doing, but only after computationally it was shown that this and this hotspot must be, could be really important. And so this is really enormous area to because it is general approach and can be used for just enormous amount of different targets, for like DNA interaction between DNA and different transcription factors and so forth, and countless number of different protein-protein interaction situations. So we suggest this is the team. We have mostly it is in Boston University. It is me. It is Dima Kazakov, who is here, who is together with Shandar Vajda developed most of these approaches I'm talking about. And so they are really internationally recognized experts in computational biophysics and chemistry. And we also have in our team Adrian Vitti, who worked for many years before moving to BU in industry, in real drug discovery area in such famous company as Biogen in Cambridge, Massachusetts. And so we also have in our team very, very great expert in X-ray crystallography, Lucy Malinina, also FISTech alumni. And we will need some synthetic chemistry to synthesize these potential drugs. That's why we have in our team William Smith, who is the only local, really from Russia. All the rest are from abroad. And just show you some our recent publication of this team and show you that we already work together in significant extent. So you see that this paper, upcoming paper in Nature Chemical Biology, where Kazakov, Vajda, and Vitti co-author, and we also have together publication with Kazakov and Vajda and me. And so this is of course, it is only a small portion of recently published papers on this theme. And also, we have extensive negotiation now with FISTech about establishing not only a research lab, but also the educational program in making the dual degree in Master of Engineering for FISTech and Biomedical Engineering Department in Boston University, where 3 of us in this team affiliated with. So this is already a significant progress in this kind of negotiation from both sides. Thank you very much.